So I'm working on a new tutorial video at the moment, and it's one of those videos where it's all about web scraping. And fortunately for us, the website that I'm getting the data from actually has one of those underlying APIs, which is great news because we get all of our data as really well formatted JSON payloads. There's about 89,000 pages, so quite a few data points to collect. And historically, we've been working with those and writing them as CSV. It's a little bit nested, and I thought, wouldn't it be nice if I just stored that in a little database? So first of all, before we go any further, let's talk about what I'm actually looking at. So this is the actual payloads themselves. They're not terribly nested. There's a couple of little nestings going on here, like data, for example, really just one. And then actually, no, I think there's more. Yeah, from data, this goes to documents. And then I think there's a couple more here where there is data available. So I've got this shallow nested sort of JSON payload from these websites, 89,000 of them. And I thought it'd be a great idea to store them into an SQLite database. If you're not familiar with SQLite, it's come standard with Python. It's a C library on disk or memory database. It's really awesome. And I'm going to show you how I interact with that in a moment. And what I was thinking is, if I'm going to store the JSON payload into the database as its own, column called payload, and each row is each of those 89,000 payloads, what I'm going to end up having is a database query that kind of pulls them all down and then potentially uses Python to convert that back into a native Python object, like a dictionary, for example. And then I got thinking, well, I've been working with other database providers recently, like Oracle, and they've got a thing that you can just go ahead and ask for elements from the JSON object within the database. Now, this is, really traditional sort of NoSQL, MongoDB style interacting. I thought, would it be cool if I could do that with SQLite? So I had a quick look at the documentation. And here it is, we've got JSON functions, which are really cool because it actually means that we don't want all the elements out of the JSON payload. We might just want 2 or 3. For example, we might just want, the name, the Australian business number, and maybe the UUID. It simply means we don't have to pull down the whole JSON payload to get that. In actual fact, we can probably get those 3 columns alone. And that's where the JSON extract comes in. Now, when you look at this, it is a little bit confusing. So why don't we take 10 steps back and jump into some Python and just come along the code with me. So what we'll do is we'll start off by importing, I'm really bad at typing when I'm looking at this microphone, import SQLite 3, shift enter on that. All that's done there is brought in the SQLite model. It's built into Python, so you don't have to worry about pip installing anything. The next thing I'm going to do is make a connection. Now, if you do look at the documentation, they sort of have a bit of a way of doing this. CON for connection, and we'll talk about cursor in a moment, CUR for cursor. Now, I'll do something similar, but you can sort of name them whatever you like, but it's kind of the best practice to sort of follow along closely to what everyone else is doing. It just makes it easier if you're inheriting code or working in a team. So I'm going to go ahead and say con with 2 N's. Don't ask me why I've always done it that way. And then what I'm going to do to connect to my database, which is just honestly just a simple file on the disk, which holds the entire database, all of its tables, everything in one place, which is really cool. I'm going to say SQLite 3.connection, connection atom. Now here is a little gotcha. Now if I type in the wrong database name, it'll just create it. It'll just create a fresh out of the packet database. So you don't want to do that. You want to make sure you name it correctly. Now there's a couple of different ways we can do that. I can have a look on the file system. Fortunately, I recently just made the database by creating it and writing to it, so I know what it's called. It's called payloads.db. But if I was unsure, I can look into the file system, or I can use the OS list dir functions as well. So let's get back to business. So where are we? So we've got the SQLite 3.connection, and here we have to specify, what are we specifying? The name of the database I created. Database is called payloads.db. Now it's the database name. Shift enter on, oh, what have I done there? Let's have a look. I've literally typed connection rather than connect. I literally wrote connect and then changed it to connection. It wouldn't be a Make That Useful video without an error. What are we, like 2 minutes in? I don't know. Okay, so we've got the connection. We know we've got the connection because we can run the connection. It will show us here that we have a connection to this database. Now, to be able to query the database, and for that matter, insert and delete, do all that sort of stuff, we do need to create a cursor object. It sounds a bit confusing if you've never sort of done this before, but bear with me. It will make a bit more sense in a moment. So to create a cursor, I'm actually going to go against the grain here and call it cursor. And cursor is a method, okay, a method that exists on the connection. So we've got the connection created here, which is this con object, and then we're going to go ahead and create the cursor. Shift enter on that, Nothing should happen. This is it. We now have a cursor. All that means is we can go ahead and query the database. I'm going to shift enter down on cursor, and you can see here SQLite.cursor, and from memory, I think that's its memory location. Not important to us, but it just simply reinforces that it looks like it's been created. Okay, cool. Now, in my payloads database, I created a table called payloads detail. And what I want to do is I want to select a column from that called payload, right? So we've got 89,000 payloads. When I say the word payload, all I'm referring to is these really nicely sort of formatted JSON payloads. Okay, it's just a string, and it's just got all the different keys and values, and sometimes they're nested in one place. Now, the whole purpose of this is we want to be able to select a couple of columns out of that and maybe display it in a Pandas DataFrame for further analysis. So to do that, what we're going to do is we are going to go ahead and write some SQL, which isn't too tricky. It's just going to be something like SQL, is equal to, not two equals, not comparing, we're assigning, is equal to select, well, I won't select all. I was going to do a select star, which would select all of the columns, but we'll do a select, payload, that's weird, payload from payload, where are we? Payload detail. Now, that's the name of the table. Shift enter on that. And all this is doing is nothing. It's just a string. So it's just a string that will pass into our cursor to be able to run against the database. Now, I know it's a string. Ugh, I'm typing all sorts of weird things tonight because I can type in type and I can type SQL and it will return the word string, which says, hey, I'm just a string, nothing special. So what I can do now is I can go to cursor and I could say something like cursor.execute. Okay, and then I can do open and close parentheses, and I can pass in my SQL, and I can shift enter on that. I knew I was going to get an error. I just always do. Okay, yeah, that's right. For some reason, I called it payloads detail. Don't ask me why it was late. So let's go ahead and shift enter on that, and shift enter again, and voila. We now have a query that's run against the cursor. What does that actually mean? So it means that this cursor, when I run the next method, can go ahead and collect the data. Now, what's interesting about this cursor, not to get too deep into it in this video, but it is a generator function, which means it can go in and sort of select each row at a time, or it can bring back all rows in one go. So what do I mean by that? Let's go ahead and find out. So when I say find out, I mean cursor.find, where are we? Not cursor.execute, I don't know. Find, fetch, Adam, fetch. It's fetch. A couple options. I press tab there. I'm in the new notebook, which is part of the Jupyter Lab thing. I think it's notebook 7. It's got really good sort of autocorrect and suggestions, like syntax stuff, which is really awesome. I could fetch all, I could fetch many, or I can fetch one. Now I'm going to go ahead and fetch one. And I'm going to open and close bracket on that. Now, I'm not assigning this to a variable. So when I hit shift enter on this, it is actually going to go ahead and return the row. Now the row is a tuple or tuple, depending on which part of the world you're from. And in there is the column that I selected, which was payload. So what does that mean when I said that this was, where are we? This cursor was a generator function. Now, if you pay close attention, you can see here the name is the trustee, etc. If I hit shift enter again, boom, next row. Okay, shift enter again. And we're just going down the row. So this is literally just fetching one at a time. Really good for testing, and in a moment we'll go ahead and fetch all. But what we're going to do is we are going to go ahead and we are going to assign all of this data to a variable. So to do that, let's just give it a catchy name like data, okay? And inside data, we're going to say, fetch, and we're going to go ahead and fetch all, okay? So shift enter on that. And now that we have that, we can do a quick check on the length, see what we're working with. There we go. Oh God, I think I said 89,000 at the start of the video. My bad, 83,000. So let's give ourselves a bit more room and let's keep working. So where are we? So now we have, if I'm not mistaken, a list, and we can test that. So type a list, and I'm gonna pick the first element of the list. So open bracket, close bracket 0, and that's gonna return this. And I believe that is a tuple or tuple. I'm not wedded to either. Oh my God, I'm typing tuple. Type on that, shift enter, it is a tuple or a tuple. For us to be able to interact with each of these JSON objects as a native Python dictionary, we do actually sort of need to get them out of their tuples. Oh my God, I should just decide what to call them. I'm gonna call them tuples. maybe tuples. It's not important. So what we need to do is we need to kind of iterate all the way through that list, and we need to select the first element within that list. So what do I mean by that? So I've got this data object, which is that big long list, and I pick the first element, and that's a tuple. And if I pick the first element, that's a string, and that's the string we're going to go ahead and do our JSON conversion to bring it into a native Python object as a dictionary. So taking 5 steps back, let's go ahead and loop through each of the items in our data list, and each time we go past them, we're just going to ask for the first element. So rather than working with tuples, we're working with strings. Now, a couple of different ways to do that. I could write a for loop, so maybe something like for item in data, okay, and I could say something like item 0, and we'll break it there, and I'll put a print around that so we know what we're working with. And again, that's going to return that sort of string, and then we can go from there. Now, a couple of things we could do is we could say something like, all records are equal to a blank list, and then all records we can actually do a dot append. And what we're going to do now is shift enter on that. Oh, no, I'm not, because I've got a dot there. All records dot append. Did I just not type it? And because I've got a break on, I should only have had one sort of record return. And I can test that with a bit of a length. Okay, so look at that. But if I take the breaks off, what that does is it says, hey, just go all the way through the list. Now when I do a return on the len, I can see there's 83,000 again. So where am I going with all this? Now this is a fun way to do it, but anybody who has spent a little bit of time with Python would put their hand up and say, well, this might be a really good candidate for a list comprehension. So just a nice little one-liner that allows you to do a for loop and fill up a list without having to do a 3-liner. So how do we do that? Well, it's actually quite easy. So sticking with the same sort of format we had before, what I'm going to do is I'm going to say something like this. I'm going to do open and close brackets for the list, and this is a list comprehension. And I'm going to write item for item, so very similar to how we had our for loop before. Item for item in data. Now, if I was to run this, which I really shouldn't, it probably will crash my computer, nothing will be different. Everything's the same here. What will change this is if I go ahead and ask for the first item, the first item in the tuple. Because remember, we've got a list of tuples. I've just changed it from tuple to tuple. We've got a list of tuples, and I want to break out of the tuple and get the first item out, so we're working with a string. So what we'll call this one is something, just to keep it separate for now, clean data. And now when I look at clean data, okay, the length is the same, so nothing's changed. It's 83,801. And if I was to pick the first item in clean data, okay, so number 0 there, it's a string, not a tuple anymore. And the reason that works is because I've said, hey, this is a list of tuples, but if I just go through that list through list comprehension and ask for the first element within each of those tuples, which there is only one, it will just return the string. Now, we've done list comprehension here, but this is still string data, and ultimately I need JSON, or I need data I can interact with, like, dictionaries. So what I need to do is I need to go back to the top here, and I need to import another library from the standard library called JSON. Okay, and what we can do is we'll just work with this one object here. We can say something like JSON.loads and pop that in there, and now we've got a native Python object, so we can interact with this just like we would any other dictionary. A couple of reasons I know this is a dictionary. One, I can write type, and when I look at that, it's a dictionary. And two, I can ask for things like dot. I can do dictionary things like give me the keys. That's where I learned that there's a type, a UID, and data. And I can ask for keys as well. So I can open and close brackets, and I can type in the word data. So where am I going with all this? Now, a couple of different things I need to do. A, I could loop through like I did before and do a bit of a JSON, sort of JSON.loads, or, and this is getting a bit technical, inside my clean data, I can maybe, and this is getting, if you've never seen this code before, it will look a bit confusing, so we might choose to break it into 2 sort of list comprehensions. But what I could do is, if you can entertain me for a moment here, is I can update my clean data to then say, okay, list comprehension, item for item in data. Again, these can say whatever we want, blah. Ooh. This is something I really struggled with when I first learned Python. It was like, well, what is a sort of keyword and what is something you're just making up? As long as these two are the same, it doesn't matter, right? Blah, blah for blah in data. Now, what's happening here is blah, before we do this, 0 is a tuple. So we need to ask for the first element within a tuple. So now we have a string. And then we're saying JSON.loads on that string, which is a valid JSON format. And that's going to then convert everything into Python native objects, which are dictionaries. So if I go ahead and shift enter on that, it's taking a bit longer this time. Well, it's taking a real long time. Any minute, there we go. Cool, so that's done now. Now when I look at clean data, which I shouldn't look at all of it because it will probably crash my browser. But if I look at the first element, shift enter on that, again, straight away I could see that the first element is a native Python dictionary and that's working beautifully. So now we're at the point where I'm saying, okay, I want to build a data frame, but I only want 3 elements in this. So what I might choose to do is I might choose to select those 3 elements and then create a data frame sort of based on that. Those elements might be everything in data, so I could maybe get away with just selecting data from each and then sort of building a data frame around that. But to stay true to our goal, let's go ahead and again, let's write a list comprehension. I'm going to do it separate to the previous one, only because we're getting a bit complex. Even this is starting to look a bit weird, and if you've never seen this code before, you'd be like, what is this actually doing? And that's where comments can help. So let's go ahead and try to select maybe those 3 columns that I mentioned earlier. So the UUID, the name, and the ABN, and let's build a data frame out of that. To do that, what I'm going to do is, first of all, I'm going to create a new variable name, and that's going to be called something like, smaller, smaller clean data, right? It's a silly name, but it's useful for me because helps me know what it is. So smaller clean data is equal to, now this one's going to be very similar to the previous one. It's going to be blah for blah in, almost clean data. So all this is doing is kind of nothing. It's saying, hey, for every element in clean data, keep it there, right? Happy days. But what we want to do is we sort of want to generate our own dictionary, which only has 3 elements. It has the UUID, the name, and the ABN. So how do we do that? So it's going to get a bit weird and confusing, but ultimately this blah here, which is the entire dictionary object, we only kind of want to return sort of 3 things from that. So what we're going to do is I'm going to say, okay, well, what I want to return is a dictionary. So I'll do that. If we ran this, all we're going to do is end up with 80-odd thousand blank. Well, in this case, it might actually be a set, but we'll end up with blank objects. Nothing will happen, right? But what I can do is, and this is where it gets a bit funky, and you might need to ask a question in the comments if any of this doesn't make sense. We've got a really good community here at Make Data Useful, and please consider subscribing if you haven't already. We're going to go ahead and define our keys ourselves. So what we're going to say is, hey, UUID, I can name that whatever I want, but I can do UUID colon, and then I've got this item here available to be called blah, and I could say, give me the UUID, okay? That's awesome. And now if I was to run that, what we're actually ending up with is something that looks like this. And rather than just grabbing the first one, let me grab the first few. So 0 to 6, 2, 3, 4, 5, 6, beautiful. That there is 1/3 of kind of what we want, but we actually want 2 more keys in there. We want the name and we want the ABN. So let's go ahead and add those in. Now, to give ourselves a bit of space, what I might do is I might actually go on multiple lines, which is okay because it's all within a list. It's not going to break. So the next key I'm going to add is going to be the name. Now, I'm super forgetful, so maybe what I'll do is I'll just double check that first item and we'll have a look at what I'm working with. So I've got data, okay, and then capital N for name. So let's go ahead and do that. So what we're going to say is you are equal to blah, and we're going to say data, okay, and then we're going to say capital N name. It is case sensitive. Let's just confirm that's looking good. Yep, that looks good to me. The only way this would give us an error is if in one of these blah sort of payloads, these dictionaries, there was no data or there was no name, and that would then give us a key error. So hopefully I'm hoping they've got names for everything, but let's shift enter on that. key error, no name. Okay, guys, we planned for this. So this is where we have to use a dictionary method called get. And the get method allows us to ask for a key, and if that key doesn't exist, it can either return none, so nothing, none, or we can tell it to return something like an empty dictionary, which will make a bit more sense in a moment, so we can then ask for the key again. So what I mean by that is we'll take a few steps back. So I've got blah, and from blah, I'm going to say get, and with get, I'm going to get data. Now, if data doesn't exist, I can pass in a second argument, which would be what am I going to return if data's not there? Now, if I left this as is, it will return none. And then if I did the second get, I might get an error saying, hey, I can't just ask for name from a none object. So what I need to do is I need to pass in a blank dictionary. Could be any dictionary, to be honest. And then from there, what I can actually do is I can say, well, if data does exist, let's go ahead and get name, okay? But if data doesn't exist and it returns a blank dictionary, it's okay to do a get on a blank dictionary. That'll be fine. If that doesn't return anything, it will just return none. But if we wanted to be really, make sure all of our data is strings, I can just pass in an empty string. So shift enter on that. And just like that, like magic, shift enter on that, I now have all of our UUIDs and all of our names. Now, if you've been a subscriber to the channel for a little while, you know that this is the perfect data set to then pass it into a Pandas DataFrame so we can start manipulating that data and working with it and transforming it, visualizing it and exporting it and all that sort of good stuff. So let's do the next part, which is the ABN. Now to do the ABN, I'm literally going to cheat a little bit and just copy this. Now copy that, paste it down. If I left this as is and shift enter, I'm just going to get nothing different because the name already exists. You can't have duplicate keys in the same dictionary. So it's like I'm defining name and then I'm defining it again. So what I'm going to do is call this one ABN. But if I shift enter, you'll notice that my ABN is still equal to the name because I haven't updated this one here. So let's go ahead and get that key, which is ABN with a capital A, which is weird because it is an acronym for Australian business name. But let's go ahead and do that. So ABN, shift enter. And just like magic, we now have the three keys that we wanted from that JSON payload that we turned into a dictionary that we then did some list comprehension and got the keys out. So a little bit of effort. Look, we could probably combine a couple of these things, but we got there in the end. Now, the final steps for me would be to then go, okay, let's go ahead and import pandas as PD. Don't ask me why, and it's a weird habit that I've got into, but I kind of want them all to be in sort of order, from longest to shortest length. Shift enter on that, and we now have imported pandas, so we can create a data frame. So to do that, I'm going to say the data frame is equal to pd.dataframe, okay? And with the data frame, what we're going to pass into that is the smaller clean data already, so which is this one here. Shift enter on that. Look at me with my weird capitals. pd.dataframe. There we go. Case sensitive, capital D, capital F. Shift enter on that. And just like magic, we now have the column name, the name that I was seeking from the dictionary, and the ABN. So it took a bit, but we got there in the end. And that would be sort of the traditional way that I would tackle this problem. I'll say, yeah, cool, let's bring all of that, JSON data into Python. Okay, it's in tuples. Let's get that back to string. From the string, let's get that into a JSON or dictionary object. From the dictionary object, let's select a few keys, and off we go. Happy days. But I want to try something different. I want to go back to what we discussed at the start of this video, which was how can I leverage this JSON extract function that exists within the SQLite database to be able to just extract those columns directly and do two things. One, see if we can cut down the number of lines of code we have to write. And two, let's see if we can make it perform a bit faster, because right now, I think this is taking a little bit of time. Now, we can test that. There's a couple of different ways to time things in a notebook. You can use, I think it's percentage time, like time it. There's a few other ones. I quite like the time module. It has a performance counter, which will take a really accurate measurement of the current time in seconds. And it will take another measurement. You can take another measurement at the end and take one from the other, and you kind of get this, hey, how many seconds did this take to run? So let's go ahead and test that. So what I might do is I might bring all this together into one cell. And I might even speed this part of the video up for you guys, so you don't have to sit through that, so stick around. Okay, so I've copied all of that code into one cell. What I'm going to do now is I'm going to say something like this. from time, okay, import perf counter. And this is that really high accuracy sort of counter. Oh, I've got a shift enter. You got to shift enter when you import things, Adam. Now if I shift enter on that, it'll show me this is the performance counter. Shift enter again, you can see that sort of moving. And if you take sort of that minus that, it should be 0, but it took a very, 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 very small amount of time to run that calculation from when the first one was triggered to the next one. And what we're going to do is really simple. So we're going to say start is equal to the performance counter. We're going to capture that. And then we're going to say end is equal to the performance counter, which will run after the program's already run. And then we're going to simply say end minus start. Okay, so let's quickly test that. So let's go start, and it's count to like 1, 2, 3, 4. It's about 5, maybe more or less. Yep, 4.9 seconds. So really accurate down to like a bazillion decimal places. Nothing that I really need, but this is really useful when you're running lots of loops and you want to sort of count up how long each loop is sort of taking, especially if you have like 10 million loops. Even a fraction of a second increase in speed can speed up the overall program by minutes or hours. So let's go ahead and implement that now. So let's go ahead and put our start at the, you guessed it, start, and let's put our end there at the end. And let's go ahead and calculate start, end minus start. So I'm not even sure how long this is going to take to run, and it probably will be dependent on a number of factors, but it's not a perfect science, but we'll get a ballpark, shift enter on that. It's taking a little while. Let's have a look. I should probably do some print statements to tell me where it's up to, and we can even do like performance for each. And this is a very, okay, 8.3 seconds, not too bad. But again, this is 89,000 records, or sorry, it's 83,000 records. Let's imagine I had 830 million for some weird reason, which I don't, but let's imagine I did. It just would be completely impossible to do it this way. In fact, it might be impossible to do it the other way. You probably want to get a database, management system when you're at that point. But 80 odd thousand, if we got 8 million, it might be, heaps lower. So let's go ahead and run it again, just to see if 8.3 is roughly the number. Anything between 7 and 9 would be good enough to sort of give us a ballpark. So let's go ahead and wait for that to return. Okay, 7.5. So that's probably our best so far. One more just to see if we can get some sort of average out of it. Put this in a loop actually, probably loop it around. And this is where the time it command magic method, percentage sign really comes into play. Okay, so we're getting it down to about 7 seconds. That's awesome. So let's go ahead and have a think about using this JSON function, this JSON extract sort of functionality. To do that, what we're going to do is we are going to still do our sort of connection, but I'm going to mix it up a little bit. So I'm going to do the connection, and I'm going to go straight down to the SQL. I'm going to show you why in a moment. So the SQL is this one here. Okay, select payload from payloads detail. What I might do is I might actually go ahead and do a couple more commas on each side, because that allows me then to do multiple line strings, which is pretty neat. And I go ahead and let's have a look at that. And now what we have is we have select payload from payloads detail. Now, if we look at the documentation, we can actually run a JSON extract. Now this is really confusing to look at. So let me show you how I have been doing it. So what I can do is I can say something like JSON underscore extract, open bracket. And we can close the bracket, but we have to actually put in what we're trying to extract. So the second argument to this JSON extract, now remember, this isn't a Python function. This is an SQLite function. This is in the database, which is really cool because SQLite isn't unique to Python. It's used everywhere. I think it's used in all Android and iPhones. And don't quote me on this, but I think it is the most widely sort of used database in the world, because every single iPhone and I think all of everything in your iPhone is an SQLite database, which is a little bit mind-boggling. So JSON extract, payload, what are we extracting? Now, we know from our good work in collecting the data, okay, let's have a look at that quickly. We know for a fact that we have these payloads, and we're saying JSON extract payload. We first have to say $, and then we have to tell it which key we're after. So first of all, we're after UUID. We'll say as UUID. Now, I'm going to cheat again. I'm going to copy that. I'm going to paste it down a couple of times, because next we're going to say, well, I don't want to just go to UUID. I want to go to data. And then from data, I want to go to name. So .name. If you've done any JavaScript, it's a very similar sort of syntax. And the next one's very similar. So data dot ABN. Okay, give them their names. So name. and ABN. So where are we? So now we've got this SQL. I'm actually going to shortcut this whole thing because originally I was returning these sort of strings and JSON payloads. I did a whole bunch of work to get into a format that Pandas would like, but because I'm able to get this into a format which I think Pandas will accept natively, what I can then do is something like, call it df2 because that's a great name, Adam. It's a terrible name, don't name them df2. We'll give this a name as p to he, right? Dot read. There's all the things you can read. We want to read, where are we? Read SQL query. In there, it gives us some options. We want to pass in our SQL and our connection. So this is some real syntax sugar. So this, what that means is like, Pandas is doing a heap of stuff in the background for us, and we're just leveraging that. So if I think I've got this right and I run that, I should then have, stuffed it. What did I go wrong there? This is called SQL. Did I not run this cell? Okay, let's actually run that, and let's run that. Oh, look, I got an error. Let's have a look at what I've done. Okay, here's a fun fact about me. I either put an extra comma in or not enough commas. So let's just quickly go over this SQL statement. So we've got select, JSON extract payload, and we're passing in this funky little $ to say, this is the root of the JSON object. I want UUID, I want data, and I want name. I'm relabeling those as column names, and I'm putting a comma after each, apart from the last one, because that's where the from statement is at. So shift enter, and just like that, it worked. Well, there we go. Woo! So what have we actually done here? So we've gone from, I don't even want to count the number of lines here, quite a few, down to really what you can call almost 3 if you put the statement on one line, or 2 to, sort of 3, and then you can actually view it. So originally we were working with about 7.15 and up to 8 seconds. Let's go ahead and test our new approach, which I'm a big fan of, to be honest. I kind of like this way of kind of passing things off to the database. That way I'm not sort of having to pull the data out, work on it, and then kind of pass it off. I'm like, hey, especially if your database isn't SQLite, it's like an Oracle database, which has very similar functionality and is hosted in the cloud or a server somewhere. You can pass off all of your compute over to that to do all the work and then return to you what you actually want to work with. So let's go ahead and again do our start and end. Let's shift enter on that, and 1.5 seconds. Not bad at all, actually. Shift enter, what are we working with? So this one's running in, we've got it down to 7 point something. Oh geez, it's taking its time this time. Oh, it's really, 9.3, 1.4, even quicker. So if I'm not mistaken, let's take the worst and the best of them because that makes for a better title. How many times faster is this approach? 6.3 times faster. And I would argue that it's, heaps less code. So look, if you want to do it this way, by all means do it. There is a computational overhead. There's a whole bunch of stuff you have to do in Python. Before we go any further, there is actually a Pandas JSON normalize approach. I had to play with it earlier today. I wasn't a fan of it. I don't particularly like it. If I was to go down the path, I'd probably end up doing this way every time. But given that the SQLite database and so many other databases now have the options to interact with JSON data in this way, this is probably going to be my preferred way of, first of all, loading data into an SQLite database. Like, why trouble yourself and have all these columns and, just whack the JSON payload in there if it's not production data and you're just sort of playing or doing some web scraping or data analysis. Just put the JSON payloads into the database and then use this JSON extract and these JSON functions to be able to collect that information into a really simple and easy way to consume. So, hey, if this was useful and you're not a subscriber, please, I would love it if you did subscribe. We are building an awesome community here. At this time of recording, we're very close to 15,000 subscribers. And if you've seen any of my earlier videos, you know how excited I got with 1,000 subscribers. So 15,000 blows my mind. I'm just so grateful. If you've got any questions or comments, you're like, hey, Adam, you're doing that wrong. Thank you so much for watching and enjoy some Python and SQLite JSON.